Okay, now we discuss on full wave rectifier. So in the case of a half wave rectifier, what you do is we have used the original signal, we cut down the lower part, but this is a missing for that one. So in the half wave full wave rectifier, we will try to use this missing part, so that we will change the directions to the upward, so that that also can be used for the signal. Okay, full wave rectifier is an alternating circuit that converts both the positive and negative half cycles of an alternating current waveform to a single pulsating direct current DC waveform. The process is more efficient than half wave rectification. We get to use the entire input signal. Okay, if you look at the full wave rectifier, there are two types of full wave rectifier. One is called a center tap rectifier, another is called a bridge rectifier. So this is called center tap, and this is called a full bridge rectifier. Okay, we'll discuss it separately. So first one is called a center tap rectifier. This design uses center tap transformer and two diodes. So there is diodes called center tap, which means that there are three inductors: the inductor 1, inductor 2, inductor 3. Here in the center of these two inductors we are earthed. Okay, this is called a center tapping, and we are giving the signal there to the transformer. This is the output is secondary of the transformer. We get a signal which is step down, and it is connected to two diodes. This is diode 1, this is diode 2, and we get the load here. So both diodes are connected together and take the output to the load resistor. Okay, so what will happen is that we are giving the signal. What happens is the diode D1 is forward biased for the cycle, and this will pass down, and that case we are getting the negative signals. This is 180 degree phase difference is there, because if it is the here is positive and we get a negative here, at that time it is reverse biased, which means there is no signal transfers. So whatever coming to the signal will pass down, so we get a first cycle. For the case of negative cycle, what will happens, this become negative, and here the 180 degree phase difference will come, this become positive, and it is forward biased. So the current will pass through this path, not this path, so they get the second half cycle. Similarly, this will continue, and we get the required signal, so that we are used the unused parts in the half wave rectifier. Okay, in the case of bridge rectifier, this type is more common and uses standard transformer and 4 diodes in a bridge configuration. The configuration name is itself called a bridge, and it is often more practical as it does not require specialized center tap transformer. Okay, here we don't use a center tap transformer. A general transformer can be used. So we have L1 and L2, and this will connected to here. The diode is organized like this. This is D1, D2, D3 and D4, and these two will connected like this, and the second one will be connected like this, and both are connected to here, and this will be connected to our load. Okay, so again we have the analysis. The positive half cycle, the diodes, two diodes will be conduct, or the negative half cycle also two diodes will conduct, and we get the required output for that. Okay, okay, so we can also improve the rectification process by adding a filter, capacity filter to this one. So what you do is, if you do some capacitive filter to this one, we get a more smoothed DC signal as the output. Okay, now we will try to implement this full wave rectification using LTspice. So for that, I already made the circuits, so you can, for the reference how we can make the circuit, you can go for the previous video, which is half wave rectifier, where I made the circuits. Okay, here we applied as a power supply of 308 voltage of 1 kHz frequencies. Then I just connected to the inductors. There are 3 inductors, L1, L2 and L3. These are coupled by this equation, K is equal to L1, L2, L3 by a coupling in constant 1. Okay, then this is center tap, should be center tap. I should connect it to ground. Then I give the diodes IN 4007 to both the diodes. Then these are connected. Then a capacitor is connected and a 1K load is connected. Okay, the transient response is about 5 milliseconds is given. So if I try to run this, I can see that here it's a signal, and we have a signal of sinusoidal signal here. And if I try to see the output waveform, this is almost like a DC signal. Okay, this is a circuit for a bridge rectifier. So we have a power supply of 240 volt is given, and we have two inductors L1 and L2, which is coupled by this equation is equal to L1 K, L1 L2 1. Then we have the diodes in bridge configurations. We have a resistor is also connected, and also capacitor is connected in parallel with the resistor. So if we try to run this simulations, you can get a signal here is sinusoidal, and if you try to get here, so you get a pulsating, almost you get a DC signal from here.